Hello, everybody. Welcome to another video. Virat here, and I'm going to be telling you about the Nvidia H100 GPU. The Nvidia H100 is a complete miracle. It really sets the standard for the kinds of GPUs that we should be using in the future. And it's not like the 4090 or 5090 as in like consumer GPUs. It's more of a server GPU, and it's useful for a lot of AI tasks, as I'll get into. And it really is like completely amazing because it's built on the Hopper architecture. And the Hopper architecture is a new architecture that they built. And after that, they're coming out with GPUs now with the Blackwell architecture. So the H200 has also released, but I'm talking about the first in line, H100, and this really shocked the world. It has the fourth generation tensor cores, and it has thousands of tensor cores. And compared to normal GPUs, they don't have that many tensor cores. And basically, what a tensor is for people that don't really know TF, it's like a unit of information, and it's especially used in AI when it comes to training AIs, inferencing, and such. And because of this, it's really optimized for deep learning. It also has an amazing connectivity. They developed their own connection software between GPUs with NVLink 4.0, and this means that they can get up to like terabytes per second of bandwidth between GPU to GPU, and I believe it's like more than a terabyte per second with CPU to GPU, and it has a data transfer protocol, not protocol, like format, which is FP8, which helps things even go even faster, and this is especially designed for AI connectivity. So compared to the 4090 or 5090, it doesn't really compare because these are completely different GPUs. The 4090 and 30 series, 50 series, these are all consumer GPUs. And for people that don't know the difference, consumer GPUs have ray tracing cores and like RT, that's like RT cores and media processing units and all those. And these are especially useful when you're playing a game of sorts. But what these are focused on are servers. They have massive amounts of storage and they can process really large loads really quickly. And especially training and running AIs, which you wouldn't use computer hardware to do more, especially at a massive scale. So it delivered 2 to 3 times better performance than its uh, predecessor, the A100. So for data centers that required GPU compute, this is an amazing change. And also has the hardware itself allows to speed up model training like 9 times faster than the A100 because of its extension of like fourth generation tensor cores, even more tensor cores, and inference is more than 30 times faster than the A100. And this is like really crucial for large scale machine learning. For a similar cost, you get like more than 10 times the amount of performance. This is really amazing for deep learning and compute. And the memory bandwidth that they have inside the GPU, it's HBM3 memory, and this is about 2.9 terabytes per second. So things just so especially if you're thinking about the scale of like trillions of parameters models in the real world, they're like even though they're just a trillion parameters, depending on the precision that they're trained to, like 1.6 or like, sorry, 16 bit or like 2 byte or 4 byte, then that means that that will make it 4 trillion parameters, and that will require about like 4 terabytes per second of bandwidth if you're like moving and using and like computing all the weights. So that like for all of those gigantic models, you need this much amount of bandwidth. And this also means that it supports massive amounts of data. So if you have to realize the large language models that are usually being trained on these types of GPUs, they're like the data sets themselves are more than petabytes in size. As the internet itself is an exabyte, and they're basically consuming a lot of the internet, and especially the image models and whatever, they need even more information because they also need images and videos and such. So this allows for large language models to be accelerated much better. And it also means that autonomous technology like self-driving cars, medical, like protein folding and like gene encoding, all of those that require crazy amounts of GPU compute. Other AI models such as image generation, multimodal, and training, all of these are use cases for these models. You wouldn't typically do rendering as like games on this GPU as it's not built for that. You do it on AI workloads. So it has like this is 4,000 teraflops per second. And that's is just a crazy amount of like throughput. No other GPU has ever reached this before, and like 60 teraflops of FP64 tensors. So FP8 is the size of the tensor, and like the encoding they use FP64 as another type. And so on these types, how fast the GPU can compute and calculate. Like I said before, it has a crazy memory bandwidth, and this is especially important for large payloads. And there's a 6 time transistor increase compared to the previous model. So this shows you model size over time. So we began with like really small models. That's like a few million parameters, then 1 billion parameters, then like 10 billion. Then we start reaching the 100 billion. That's like the modern era compute. And then finally we have the trillion parameter models. This includes uh, like GPT-4 and Grok. And so as you can tell, each one of these scale ups is a 10 times increase. So in about like it's been 7 years, 10 to the seventh is 10 million times. So we've definitely increased the model sizes by over a million times. So going from 0.1 million to 1 trillion is no easy feat. And our compute has to keep up with that. And that's why these H100 GPUs have up their H100 to be innovative. And this is especially useful in the cloud race. And the thing is, companies are spending millions and billions, even dollars in training and buying GPUs and building data centers, especially large compute companies such as like AWS, Google, and Microsoft. They're definitely going to buy all these GPUs. And this means that like H100s worldwide are like in short supply. And this is crazy because at the time there was no other GPU like it. And a bunch of companies, they were all racing to buy these. And that caused Nvidia's stock to just like shoot up like crazy. And this meant that Nvidia had to keep up with increased supply, and then like they were speeding up the H100s even more and writing like crazy drivers and such. So there was a lot of things that went into this. And there's could also be helpful for actually like not just AI, but beneficially for like other fields as well. Like I said, like genomics and drug discovery. So um, protein folding is a really intensive computing task, and there isn't enough compute that has like the amount of compute that you need is just insane to figure out like between every single molecule, what interaction causes it to be in the right way. So this can be used for treating prions of finding the right drug or targeting specific enzyme or such. And climate modeling and finance. So the faster your GPU is, the better it can train models. So this can literally be any type of model that includes analysis or trading bots. And especially if you're running at this high speed, then you can like run really big, really strong models really fast. This also applies to robotics. So Nvidia, they is a few lines of previous and current research. They've been working on creating robotics environments in the real world where they simulate the robot virtually, so they can go through millions of years of training just in like a few days through GPU, and this can help even more toward that, making that even faster. So, in conclusion, the significance of the H100 GPUs is they really redefine the performance standard for AI and like computing, and it also means that it allows for greater innovation. So, if there's anything that we weren't computationally able to do before, like protein folding at a large scale, or performing like using and training even larger models that are more like tens of trillions, then you really need even faster performance, and that's why it allows space for more innovation. And it also, this is just the beginning. It lays a foundation toward even stronger GPUs, as now we have the H200 as well. So that's it. Thank you for listening, and have a great day.